Welcome to another video. Let's walk through this physics question on the board. We have two questions. A. Calculate Roman numeral 1, the electric intensity, and Roman numeral 2, the potential at a point midway between 2 point charges of 10 to the power of minus 9 coulombs, okay, and negative 10 to the power of minus 9 coulombs. Okay, this is positive 10 to the power of minus 9 coulombs, and this other charge, okay, has a magnitude of minus 10 to the power of minus 9 coulombs, which are 20 centimeters apart. So it means that for the first question, that's question A, okay, let's say we have two conductors, okay. The first conductor carries a positive charge, okay, of magnitude positive 10 to the power of minus 9 coulombs. The second conductor carries a negative charge of magnitude negative 10 to the power of minus 9 coulombs. The two conductors are separated, okay, at a distance of 20 centimeters apart in air. So their distance of separation is 20 centimeters. Now, our task is to calculate electric intensity at a point midway between the 2 point charges, okay. So which means in this case the electric intensity at a point midway between the 2 charges will be the vector sum of the electric field intensities from each charge. Electric field intensity is the force experienced by a unit positive test charge placed at a point in an electric field, or it can be expressed as the force acting per unit coulomb of an electric charge, okay. That is a force in Newton acting per unit coulomb of an electric charge. So in this case, okay, midway between the 2 point charges will be 0.1 meters, okay, when the distance is 0.1 meters. So which means that the electric field intensity due to charge Q1, okay, due to charge Q1 is E1, okay, is E1. Remember, electric field intensity is a vector quantity, okay, and because we know that electric lines of induction or electric field lines of force, they move away from a positive charge towards negative charge. So this is the negative charge. While the field lines of force or the field lines of induction, they come into a negative charge. So which means the electric field intensity due to charge Q1, okay, is E1 because the field points or move away from, charge Q1. So we're going to make use of this formula. Electric field intensity equals to KQ1 over R prime raised to the power of 2. Now let's note this. The distance of separation between the 2 point charges is 20 centimeters. And this is 0.2, in meters. So the distance midway between the 2 point charges, okay, okay, is R prime, and that will be 0.1 meters, which is half of 0.2. So in this case, we're going to have E1 to be equals to 9.0 times 10 raised to the power of 9 multiplied by 10 raised to the power of minus 9. That is because the value of K is 9.0 times 10 raised to the power of 9. 9.0 times 10 raised to the power of 9. Okay, so this will be divided by the distance midway between the 2 point charges, and that will be 0.1 raised to the power of 2. Of course, this will be 10 raised to the power of 9 minus 9. That will be 0. So we're going to have the electric field intensity due to charge Q1 to be 9 over 10 raised to the power of minus 2, because 0.1 raised to the power of 2 will be 10 raised to the power of minus 2. And then this will be 900 Newton per coulomb. So this is the electric field intensity, okay, electric field intensity at a point midway, okay, due to charge Q1, okay. Then also the electric field intensity, the electric field intensity, the electric field intensity due to charge Q2, due to charge Q2, okay, is E2, okay. So for E2, we're going to have 9.0 times 10 raised to the power of 9 multiplied by Q2 over R prime raised to the power of 2. Let's not forget that R prime, okay, R prime represents distance midway between the 2-point charges, that's 0.1. So that this will be electric field intensity due to charge Q2 will be 9 times 10 raised to the power of 9 multiplied by 10 raised to the power of minus 9 divided by 0.1 raised to the power of 2. So that this will be 9 minus 9, that will be 0. So this will be 9 over 0.1 raised to the power of 2. Electric field intensity due to charge Q2 will be 9 times 100, okay? And the value of E will be 900 Newton per coulomb. So this is the electric field intensity due to charge Q2. So let's not forget that our task is to calculate electric field intensity at a point midway between the 2-point charges, and that will be the vector sum of the electric field intensities, okay, from each charge. So which means electric field intensity at a point midway between the two charges, okay, between the two charges, which is, I'm going to denote that with E, okay, is the vector sum, because electric field intensity is a vector quantity. So it's a vector sum of the field intensities, okay, the field intensities, okay, from each charge. So it means that this will be equals to the sum of E1 and E2. So the electric field intensity, okay, at a point midway between the 2-point charges will be 900 plus 900. The unit is Newton per coulombs. So this will be 1,800 Newton per coulombs. That's it. Then also Roman numeral 2, calculate the potential at a point midway between 2-point charges of magnitude positive 10 raised to the power of minus 9 coulombs and negative 10 raised to the power of minus 9 coulombs. Okay, midway. All right, so for field potential measures the work done in carrying a unit positive test charge, okay, from infinity, okay, to a point. So which means field potential in this case will be V equals to, this is the formula for field potential, which is the work done in carrying a unit positive test charge from infinity to a point. So we have V equals to K Q over what? Over R. So it will be R prime in this case. Okay. So the field potential due to charge of magnitude 10 raised to the power of minus 9 coulombs. Okay, this is field potential due to charge positive 10 raised to the power of minus 9 coulombs. So this will be 9 times 10 raised to the power of 9 multiplied by 10 raised to the power of minus 9 divided by 0.1. So that V1 will be equals to 9 over 0.1, and this will be 90 volts. This is 90 volts. Okay, 90 volts. Okay, then field potential, due to, we have V2 to be field potential. Field potential due to charge Q2, that is charge of minus 10 raised to the power of minus 9 coulombs. So we have that to be V2 equals to, we are using, let's not forget that this is KQ1 over R prime. Okay, so this will be KQ2 over R prime. R prime is the distance midway between the 2 point charges. So V2 will be equals to 9 times 10 raised to the power of 9 multiplied by 10 raised to the power of minus 9 over 0.1. Now, in this case, we have to consider the sign on the charge, okay, on the two charges. So because this is positive, of course, the value of the field potential will be positive. But in this case, the sign of the charge on the second conductor is minus. So this will be V2 will be equals to minus, so this will be minus 9 over 0.1, and this is equals to minus 90 volts. So field, that's the potential at a point midway. So the potential at a point midway will be V equals to V1 plus V2, and that will be 90 minus 90. So this will be 0 volts. Okay, 0 volts. So the value of V will be 0. 0. That will be 0. All right. Then B, to produce an equally large electric intensity midway between two large area parallel plates, 2.0 centimeter apart in air, what potential difference will be needed between the parallel plates? Okay, between the plates. So it means that in this case, we're going to use the formula, okay, connecting electric field intensity with potential, that is electric potential. Okay, so what potential difference? Now, potential difference, we want to know what potential does to produce an equally large electric intensity midway between two large area parallel plates, 2 centimeter apart. So the distance is 2.0 centimeter, and this is same thing as 0.02 meters. Okay, what potential difference would be needed? Okay, what potential difference would be needed, okay, between the plates? So in this case, we're going to make use of the electric field intensity at a point midway between the 2 point charges, which is the value we have here as 1800, okay, 1800 Newton per coulombs, or the unit can as well be volts per meters, because here we are using what we call potential gradient. Okay, so it means that electric field intensity will be potential difference, okay, over distance. So to calculate potential difference will be equals to the product of field intensity and the distance between the two plates, okay, the two parallel plates. So potential difference will be equals to 1800 multiplied by, so this will be 0.02, which is 1800 multiplied by 2 over 100, and then 2 times 18, this will be 36 volts. So which means the potential difference that will be needed will be 36 volts. 36 volts. The noblest pleasure is the joy of understanding. Bye-bye.